Okay, so welcome back. This is part 10 in our series. We're going to help you to build a fairly full-featured 3D ray tracer using our GPU. And I encourage you to look at the previous videos. We first started out looking at a fairly full-featured ray tracer from some NVIDIA code that did shadows and reflections. And one of the limitations was that it only rendered simple spheres. So we then found some code at scratchapixel.com that would allow you to render any arbitrary object. The challenge with that was that it used a custom object format called a .geo format. So since that's not going to work for us, we want to be able to, for example, here we are in Blender, we want to be able to build an arbitrary object in Blender and export it, and then bring it into our ray tracing code so we can actually use it for something useful. So what we're doing now is we're trying to figure out how we can, for example, here in Blender, we've got a simple cube. We showed how we can export this as a .obj, a wavefront OBJ file. We could build an object and export it and then bring it into our arbitrary object ray tracer from Scratchapixel. In this video, we're going to look into how we can actually take that OBJ file and match that to what we need from the Scratchapixel ray tracer. So here's just an example of some of the stuff that we have, some of the requirements we have for the Scratchapixel, what it needs to import an object. And here's what our OBJLoader is going to give us after we use it to import our .obj file. And the challenge here is going to be that you need some stuff as input to the Scratchapixel code so they can generate what it calls a triangle mesh. And you've got different stuff that's available from the OBJLoader code. So we're going to have to dig into what we're going to do with this OBJ code to make it so that it matches the needs of the Scratchapixel code. For example, Scratchapixel input requires the number of polygon faces. In the OBJLoader, there really is nothing that specifically says what the number of polygon faces is. You have to dig into it and find out where that data is available. So it's a bit of a challenge. For example, it loads the OBJ file into a mesh object. And ideally, you would think that the mesh object has number of faces and some of the important data as properties. Unfortunately, it doesn't. So that's one of the joys we're going to talk about of open source software. You get what you pay for. So what we're going to do is look at how we can figure out what this OBJLoader is actually doing and then match that to the requirements of the Scratchapixel code. So as we talked about previously, our simple cube that we exported from Blender is going to have some properties that we need to understand. Again, it's got 8 vertices. Each vertex has XYZ coordinates called position, and they're all assigned an index number. It's also got 6 faces, 6 quadrilateral faces, and each face is defined by the indices of the vertices that comprise the face. Then it's got 6 normals, 1 for each face. And also what we've done is we've triangulated those faces. And that means if there's 6 faces, there's 12 triangles. So that's the core of the data that we're going to be operating with. We just need to figure out how to extract the important data from the OBJLoader. So here is our OBJ file for the cube that we exported from Blender. And you can see it's got all this information. Basically, as we talked about before in previous videos, it's got a line that starts with an O, which defines the object name, and then V for vertices, and then VT for texture coordinates, and VN for the normals. And then down here, the F lines define the faces based on the indices of vertices and normals and texture coordinates. So it's a fairly simple object file, and we just need to make sure that we understand what all this stuff is coming out of the OBJLoader so that we can feed it into the Scratchapixel. So let's start with a little overview of how the OBJLoader works on our object file. Basically, as you can imagine, it takes these input lines of object files, and based on what the starting characters are, it will parse that and feed it into different, in this case, vectors. So our vertices, there are 8 vertices. It will fill in a vector of vec3 and call it positions. All right, those are the vertex positions. The texture coordinates we're really not going to talk about. We're going to focus just on the vertices and the faces. But there's 14 texture coordinates. It calls it t-coords. The normals, there are 6 of them, 1 for each face. It saves it as a vector of vec3 normals. And then it's basically just going to fill in these vectors. But then when you get down to these faces, we talked about in previous videos on OBJ files, these are all the indices of all of these vectors. And this is where all the work is going to be done on these face lines. It's going to take all of these positions, t-coords, normals, and these face lines, and from that it's going to generate what's called a mesh. These sets of faces define 12 triangles. We said before it's 6 faces. Each face has 2 triangles. So these are all the triangle faces. And you can see they're triangles because they've got 3 sets of data. If it was quadrilaterals or 4-sided, it would have 4 sets of data. But this has 1 set, 2, 1, and 1, and a second 3, 2, and 1, and then 1, 3, and 1. So this face is a triangle. The first number in each of these is the index of the vertex. So number 2 is the second vertex, -1, 1, and 1. All right? And then the third vertex is -1, -1, -1. And then the first vertex is this. So these 3 vertices define this face. All right? So you've got 12 triangle faces and you've got all of this data. So let's see what this OBJLoader does with this information. First, it runs a method called generate vertices from raw object. As we will see in this OBJLoader, and honestly with most open source software, the naming terminology is really poor and you have to dig into it to figure out what it's talking about. But it runs this method, when it goes evaluating these faces, it runs this method to generate vertices from the raw object. And a vertex is kind of a object, a class, and it fills those classes of vertice objects from the raw OBJ file. And then it does what's called vertex triangulation, misspelling of this method, but it triangulates these faces if they're not already triangulated. In our case, we saved it as a triangulated mesh, so it kind of ignores that triangulation. But if it has some faces that are quads or n-gons, it will triangulate them. What it does is it takes its first face line and parses these sets, the 3 sets of data, and assigns them to this S-face vector of strings. Again, S-face is a very poor naming for variables, and we're going to talk about that later, but I think what it means is it is a string of faces. Anyway, but basically it parses those into, in this case, 3 vertices, the string representation of the indices of 3 vertices, and puts that into a vector of 3 string elements. And also, as we said before, the size of this tells us how many vertices per face for this face. So that will come in useful a little bit later. So basically it sets up an S-face vector of 3 strings. Then it takes those 3 strings and further parses them into what's called a vertex class. So each one of these strings gets parsed into a vertex object, which has a position, which is the first one, a texture coordinate, which is the second one, it's the vec2, and then a normal, which is the third one. So each one of these becomes a vertex object. Once we've got these vertex objects, we can go through and parse them more. So we've got all these vertex objects. What it does is it then goes through and adds them to a vector of vertex called vertices. It also allows for incomplete sets of data. In other words, if for some reason it wasn't 3 numbers in this string, if it was only 2, say the normal was missing, it would go through and calculate the normal as best it could, doing a cross product. But there's some code in here that allows for incomplete data, just so we know. There's also a vertex triangulation, misspelled, which does similar stuff for the indices, and we'll talk about that in a bit. But what we're going to find out with this open source free code is what I have found over many years, is that there's an old saying, you get what you pay for. And I know a lot of people love open source software because, for one major reason, it's free. So being free erases a lot of negative aspects. But for me, not so much. I'm more about quality and, not having to waste my time on code that is poorly written and very difficult to understand. What we will find in this OBJLoader code, it's nice that somebody, has a hobby and they upload stuff, but the problems with open source, I have a lot of problems with open source, and I try to avoid it if at all possible. Nobody has to prove their qualifications when they upload open source software. It doesn't have to be a certain quality level. It doesn't have to be documented. It's, you get what you pay for, and this is no exception. Just some examples of how challenging it is to try and figure out what's going on with open source software. Here I've made a list in this object loader, OBJLoader, of some of the variables and the variable names. And if you look through this, your brain might explode trying to figure out what are they talking about. For me, from an engineering perspective, you want to make something that is reliable and understandable and easy to debug, because if you have to go back and figure out what went wrong, you need to understand it, even if you haven't looked at it in 2 years or whatever. So here's some of the variable names, and honestly, it's taken me a long time trying to figure out what this is all meaning, and I still haven't gotten there. Example, variable names: vverts, vvert, iverts, tverts, overts, svert, loaded vertices, and vertices. And then there's I indices, O indices, loaded indices, and indices. Then there's space. There's positions, I positions, normals, I normals, snor, vnor, curline, and I curline. Now, if you're like me, it's nice that you get free software, but my goodness, I mean, if this makes sense to anybody other than the guy who wrote it, I will be amazed. But there's no consistency, there's no explanation of what this is, the documentation doesn't exist. And I think it's very unfortunate that people just kind of download stuff without thinking and hope it works, but not really know what's going on under the hood. I'm the other way. I need to understand what's going on. I need to know what these variables mean. And I'm the kind of person who's going to go through all of these variables and rename them to something that makes more sense. Vverts, does that mean a vector of verts or a value? S seems to mean string. So if string vert and vverts, is one a string, one is a value or a vector? I, is that an integer or an index? T, O, good luck figuring all this out. And it really makes it difficult trying to merge this code with our Scratch-a-Pixel code, trying to figure out, if we have the exact same thing that we can use. So now let's take a look at this OBJLoader. It's basically one header file, which is nice. And we'll look through this, and what I've done is I've collapsed all of the code into sections so that we can get a general overview of what it's doing. Now, as you can see here, header file pragma once, and kind of funny that for an include IO stream, include vector, they add comments about that you're including IO stream, which is a standard IO library. Thank you very much, but honestly, that's kind of a waste of comments considering that the rest of this thing has very little documentation or useful comments. So one thing I'm going to do is clean up some of these, but it starts out with an OBJL namespace namespace that holds everything that is needed and used for the OBJ model loader. So we got a structure, a vec2. So you can see we're going to be doing some making our own vectors, vec2, vec3. There's a vertex structure that holds a position, normal, and texture coordinate. And then there's a material structure, and there's a mesh structure. And you would think that the mesh structure would hold and make readily available all of the data we're going to need, like how many faces, are they triangles, or all of that stuff. But in fact, it's a simple mesh object that holds a name, a vertex list, and an index list. And as we can see, there's really nothing to it. There's no properties of information about that mesh that can, help us know, give us some data about the mesh. So we're going to have to add some stuff to that mesh object to make it so that we can interface with our Scratch a Pixel code. Then there's a math namespace, and there's a bunch of math stuff that we can use for the matrices and the vectors and so on. Then there's an algorithm namespace that has a bunch of algorithms basically for parsing the input OBJ file and converting it into vectors and so on. And then the workhorse is the loader class. And this is the class that goes through and does all of the work to parse the data and turn it into useful vectors. Let's focus first on this loader class. And what we're going to, as you can imagine, we're going to, in our code, we're going to instantiate a loader class and a constructor and destructor, and it's going to load the file. So there is a load file method. You give it a string path, and it's going to do some basic checking to make sure it's okay. And it's going to assign some vectors of positions, coordinates, normals, vertices, and so on. And it's going to generate a temporary mesh object, as we showed before. Here is the while loop that basically goes through each line of the object file, gets the line, and parses it to find out what it is, and assign it to the appropriate vectors or mesh object. Here is got some, if you want console output, I'm going to erase most of this stuff because honestly, here we're just starting with the inputting the file, and already it's sending out console output of vertices, texture coordinates, normals, and it doesn't work. It seems like for some reason it's doing it before it's even read in the data. So I'm going to make my own console output on data about the loaded mesh. And then here what we're going to do is there's a group of if statements that parse the input object file. So what it's going to do in this while loop, while it's still getting a legitimate line, if the first token, if the first character in the OBJ file, right? So it's checking these first characters in the object file. So if the first token is an O, which means it's going to have the name of the object, then do one thing. If it's a V, which means it's a vertex, you go through and you do, basically what you're doing is you are setting a, here's our S pause and V pause, and you're assigning the parsed float versions of these to the V pause X, Y, and Z, and pushing those into this V pause. And you're doing the same for texture coordinates, normals. But down here in the face section, which is this really important part, it's got all the face definitions based on the vertices and indices. This face is where it does most of the work. And you can see what it's doing is it is generating V-verts. Again, hard to figure out what it is, but it does a generate vertices from raw object, which means what it's trying to say, I think, is it is generating a vertex object from the data in the raw objects, and you're feeding it the positions, coordinates, normals, and current line. And then it is saving that somehow in loaded vertices So there's a difference between V-verts vertices and loaded vertices, and it's kind of confusing. But you've got the indices, it does the same thing, but before it does that, it does a vertex triangulation, again, a misspelling, and it does something with the indices. And honestly, I'm still working on trying to figure out what it's actually doing. But you can see it basically is parsing stuff and making meshes and vertices and indices. And then here it is, once it's got all the data, it is pushing into this loaded meshes vector. And this allows you to load multiple objects in one OBJ file. So the nice thing about this is you can do multiple objects and have multiple loaded meshes from your scene. And then it does some material stuff and then returns. And you can see it's got some vector mesh, loaded meshes, some mesh objects, some loaded vertices, which is vertex objects, loaded indices, which is a vector of integers, and then materials. And then here are the private methods: generate vertices from raw OBJ, and then the vertex triangulation, where it goes through and does a lot of stuff, and then it does load materials, and then that's about it. So our challenge is going to be kind of reverse engineering all of this and seeing what it's actually doing, and then figure out how we can plug that into the Scratch-a-Pixel code so that it can make its own triangle mesh. So I guess the question is, are we willing to go to all the effort to reverse engineer this object loader and try and integrate it with our Scratch-a-Pixel Raytracer? Well, if you look at this Excel spreadsheet, I think it perfectly summarizes the situation. I think for a lot of tech people who are doing videos, especially when you get into real technology and software and engineering type stuff, here is a chart of the viewers that this particular series in GPU ray tracing has had over the last month and a half, and I've released 8 videos, and you can see the viewership. At this point, the first video got a little bit over 300 views. And for most channels, that's laughably small. I'm 300 views in 6 weeks, but that's kind of typical for my channel. So the first video came out, and I think a lot of it was people who saw GPU ray tracing, said, cool, maybe I'll get free code. The second video came out and nobody watched it compared to there was like 73 versus 300. Basically, it's what? No free code? I'll go play video games, and nobody watches. The second video, a few more people watched it, but by the third video, it's down to my typical, which is 40 or 50 views in a video. And then the last 2 are down to 20. So you got to ask yourself, is it really worth the effort to go through and produce videos when nobody watches? Anyway, if you're one of those people who's actually watching this video, congratulations. Extremely rare for people to watch my videos, but even so, those who do watch it only watch the first 4 minutes. So it's kind of a waste of effort. I'm not sure where I'm going to go with this series, but we'll think about it and might go off in a different direction since I'm losing interest with this ray tracing, since I get no positive comments and no views. So anyway, if you're still watching, if you like any of these videos, hit the like button, subscribe, hit the bell notification. Most of all, please let other people know that we're here so I get more than 20 views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.